Recording class. So, geometric sequences and geometric series. Let me just explain the difference between a sequence and a series. The difference between a sequence and a series is that a sequence is just an ordered set of numbers, whereas a series is it's separated by plus signs. Okay, so a series is when you add them all up together. That's what you get, okay? So the geometric sequence in comparison to an arithmetic sequence is one in which, if you were doing it recursively, you multiply the previous number to find the next number. Whereas an arithmetic sequence, you add the next number to get the next number, okay? So as you can see here, if I take some number, like in this case 2, and I multiply by what each time? 3, I get the next number. 2 times 3 gives you 6. 6 times 3 gives you 18. 18 times 3 gives you 54. And the answer to this is yes. Okay? Good? Where did I get the 3? I looked at it. Well, what's the opposite of multiplying? Dividing, right? So if I want to figure out what I'm multiplying by to get this number, if I divide and I get the same number each time, that's the number I'm multiplying. If I take n plus 1 and divide it by n, and I get a constant number, that means that it's geometric. Okay? So in this case, if I divide 6 by 2, 18 by 6, 54 times 8, divided by 18, 162 by 54, I will always get 3. So yes, it's geometric. Okay? And the way you define it explicitly is this is the beginning number, and this is r, and r is called the constant ratio. Okay? And so in this particular case, I could define this explicitly as a sub n is equal to a sub 1, which is 2, times 3 raised to the n minus 1 power. So if I wanted to find the 1, 2, 3, 4, 5th term, for example, that would be 2 times 3 to the 4th power, which is 2 times, what's 3 to the 4th power? 27, 81, and 2 times 81 would actually give you 162. So, okay, or you could go recursively like we did here. 2 times 3, 6 times 3, 18 times 3, 50. But that's kind of a pain in the neck. Yes? Okay, is that hard so far? We'll see how you do on this tomorrow. Oh! Oh, we're in a different chapter. No, we'll see how, I said Will's name. I wanted to cover that up because I'm not supposed to say anyone's name on YouTube. Okay? So, we'll see how you do on this Friday. All right. So, show that the sequence is geometric. Okay? In order to do that, so if S, this is kind of what we did with the arithmetic. You're not going to like this much. S of n, we know, is equal to 2 to the negative n. So what would S to the n plus 1 be, the next term after that? 2 to the negative n. Yeah? Who said that? Antoine said it. Is 2 to the, I plug in n plus 1 in there for n, which when I simplify that is 2 to the negative n minus 1. You understand that? That would be the next term in this particular sequence. Well, to find the common ratio, the constant ratio they call it, is I have to divide this number by this number. So to show that a sequence is geometric for any value of n, if I divide this by this, and I end up with a constant, something that doesn't have a variable in it, then I know that is geometric. So I have to go 2 minus 2 to the minus n minus 1, and I want to divide that by 2 to the minus n. What do I do with these exponents to simplify that? Subtract them, okay? So I'm going to go minus n minus minus n. What's minus n minus minus n? Or minus n plus n, really? 0, right? So when I subtract, I get 2 to the 0. What's minus 1 minus nothing over here? Minus 1. See that? Okay? Because when I have to subtract the like terms, right? So negative n minus minus n makes plus n, right? So it becomes minus, these n's cancel out, and then I have minus 1 minus nothing. So what I have is 2 to the negative 1, which is equal to 1 over 2 to the 1, which is just 1/2. So this represents a geometric sequence whose common ratio or constant ratio is 1/2. Okay? And you would do this the same way, but I'm not going to do that one. Okay? It's not that hard. All right. Okay. I'm not going to do this one because you guys are gifted students and we don't want to bore people. Right? Right. Yeah. Okay. So for this one, given the geometric sequence, find the nth term. So first you want to define this geometric sequence probably explicitly, meaning I want to plug in 9 and see what the answer is. So how would I find the common ratio? Or what's r equal to? 9. I take a number after it, like I take one number in the sequence and divide by the number previous to it. So r is just 9 over 10, given that it's geometric. And that should be the same as this divided by this, just to show you that it is. 81 over 10 divided by 9, right, is the same as multiplying by 1 over, divided by 9 is the same as multiplying by 1 over 9, right? Which gives you what? 9 over 10. So when I divide this by this, I also get 9 over 10. And if I did this divided by this, I also get 9 over 10. So r is 9 over 10. So I know that a sub n is equal to a sub 1. What's a sub 1 in this case? 10 times the common ratio, which is 9 over 10, raised to the n minus 1 power. So that's the formula for this sequence. Okay? So now I am just going to plug in 9 in here. Uh-oh. Are we going to get some big monster number? We are. Okay? Find the 9th term. I don't know what the 9th term is. It's 10 times 9 over 10 raised to the 8th power. Okay? Whatever. So that becomes some ugly looking fraction. Which, what? Yeah, which is, it would be 9 to the 8th, which is a big number, over, it would be 10 to the 8th with a 10 on the top, so you would have a 10 to the 7th on the bottom, right? Okay? So that's what that fraction would look like. 9 to the 8th over 10 to the 7th. Find a recursive formula for this sequence. Okay? So recursive formula, you start with the first term, a sub 1, which is just 10, and a sub n is equal to the previous term, a sub n minus 1, times something. Times what? Times what? What did I times this by to get this? 9 over 10. That's a recursive. That's the recursive formula for that sequence. Okay? Is that hard? Not hard. Right? Okay. So for geometric sequences, you have this nice formula for the sum of a geometric sequence where r can't be 0, because then you wouldn't be multiplying it by anything. If r is 0, then it'd just be 1 over 1. Okay? So the sum of any geometric sequence is the first term times this. So how does that work? Okay? If all you do is plug and chug into this formula here, and so you plug in, find the sum of the first n terms. So what I want to do is find the first term. What would a sub 1 be in this case? If I plug in 1 in here, what do I get? 1/2, right? So this would just be 1/2 times 1 minus, the ratio is what? What am I multiplying by each time? What am I multiplying by each time here? Hello? 1/2 times 1/2 raised to the n over 1 minus r, which is also 1/2. What's 1 minus 1/2? 1/2. And you can do this. Did you know you could do that? Like that? And so what you end up with is the sum, which we'll call S sub n, of this particular sequence is just going to be 1 minus 1/2 raised to the n. Okay? So for instance, say I wanted to know what the sum of the first 1 plus 1/2, what would come next in this series? What would come next? Oops, that's not the first term. Okay? 1/2, that's the first term. Plus 1/4, plus 1/8, plus 1/16. Say I wanted to know what the sum of the first 4 terms were, right? If I plug in 4 in there, I go 1 minus 1 over 16, which would be 15/16 if I added all those up. See? Yes? Okay. Use a calculator to find the first 15 terms? Should we show you that? No. Let's wait. You could watch it on YouTube. Okay? So, I'll stop here. I'll save this.